to episode 3A. Today we're going to be talking about the method of undetermined coefficients. And so, what is this? So let's suppose that we have this function a b y prime plus c y, which we should be familiar with. We should know how to solve this. Is equal to g. And then I'm just going to say g is equal to, so I'll just write it up front here. G is equal to e to the power of, I don't know, wt, right? So how do we go about solving this or finding this? So obviously if we set this to 0, we can basically say, okay, y is equal to e to the rt, right? When this equals 0. So we found a fundamental solution set. So we have y1 and y2. You can find that really easily. But what about but how would we go about yp, our particular solution? So this is where the method of undetermined coefficients comes in. And all we're going to do is we are going to guess. That's it. Pretty much it. We're basically making an educated guess of what our function, what our particular solution might look like. So in this case, so we're going to think about, okay, how can we think about making these guesses? So the first case is when we have an exponential function like this. Well, what would a particular solution to this equation look like if we're supposed to get a exponential function out of this? And the answer is probably an exponential function. So I'm just going to e to the power of omega t, right? So it's probably probably going to look something like that, right? So let's do that. Let's just substitute yp plus byp prime plus cyp equals e, right? So when we actually go ahead and do that, well, we're going to find that we get e omega t equals omega t, and then a omega squared plus b a omega plus ca, and maybe I'll just redo all this. There we go, clean that up a little bit, and then I'll rewrite this a omega squared. So I'm going to put big A here, e omega t here, plus b omega plus c, right? And then all we can do is we can pretty much just solve for this equation now, right? And actually I should probably mention that we probably wouldn't want to have, we're going to have some constant. I'm just going to call this big C here. We're going to have some big constant C, right? And then basically this is just, okay, we can just find A is equal to, in this case, A is equal to whatever C is over A omega W squared plus BW plus C, pretty much, right? And so that becomes our solution. So, okay, in this case, y is equal to C1 y1 plus C2 y2 plus C over this e to the wt. So that's essentially it. We make a guess, an educated guess, plug that into y, and then we're going to get a system of equations that we're going to then solve. But let's think about something more complicated. So what if, so this is obviously going to be our g. So what if g is equal to like c sine omega t, right? What do we do then? So really quickly, suppose you make a guess. A sine omega t, right? That's going to be our yp. Well, we're quickly going to actually find that this isn't quite right, because as we do this thing, so we take y prime, we're going to get a, take y prime, we're going to get negative a omega squared sine, and then y prime is going to be not negative, it's going to be a omega cosine, right? And now we have this awkward cosine term. And so what's going to happen is we're going to end up with I'm not going to write the full equation because I'm going to run out of space, but actually I'll try it. A of minus a omega squared sine omega t plus b a omega cosine plus sine whatever, right, is equal to sine. So because we have this cosine here, this has to be 0 just by the implication because we have no cosine. So we end up with this system of equations. So you have this minus a whatever plus whatever equals c. But then we also have b a omega equals 0. So already that's a contradiction, right? Because this would imply that, well, if we make our guess, a is equal to 0, and if a is equal to 0, our particular solution is equal to 0, which doesn't help us. So we need to actually take make a guess that accounts for that cosine term, and that is going to be, so y prime is going to end up looking something like a cosine omega t plus b sine omega t. So that becomes our guess. And if you actually plug this in, you're going to find that this this works, right? You go ahead and you do that. You find y prime is equal to b cosine omega t, and then obviously this w goes in the front, minus a omega sine, and then y double prime is equal to negative a w squared cosine omega t minus bw squared sine of omega t. And okay, let's try plugging this in. We get a minus a w squared, and then I'm just gonna put a big C for the cosine, minus a b omega squared big S for the sine, plus b w big B big C minus b a w s plus c a big C plus c b big S, and this is equal to, okay, this big C and sine, right? So this constant times this sine omega t. So I'm gonna separate this out a bit. We get separate the cosine bits and the sine bits. So we'll start c times a plus b w b big B minus a big A w squared times cosine omega t plus c b plus minus b a w minus a big B w squared. sine omega t is equal to c sine omega t. So now we get a different system of equations. So we get so this is equal to 0 and this is equal to c. So we can write this out again. C CB minus BA omega minus A big B omega squared equals 0, and then actually if you rewrite this in terms of B only, we get minus BW times A plus C minus AW squared B is equal to C, and here we get this is C minus AWA plus BWB equals 0. And so this becomes a linear system of equations. You can pretty much plug into a matrix and solve at this point. C and 0, so this is obviously our big constant C, and then C minus AW squared, and BW. Alright, so we get this system of equations. Basically, you row reduce this matrix and you're going to solve for A and B. And we can go ahead and do that, I suppose. Do I want to? Particularly not, but this will be 1. We get C over minus. Actually, I'm not going to go ahead and do that, but basically this gives us a linear equation that we can solve. We can solve this and solve for A and B, and that's going to be our particular solution. So what is y going to look like in this case? Well, y is going to look like c1 y1 plus c2 y2 plus a cosine omega t plus b sine omega t. Okay, so that's fine. That's fine. And then there's one more case to consider here. And well, what if G is a polynomial? Or okay, so then that's gonna look like something A, or C t to the power n plus d t to the n minus 1, or plus d t, something, right? Well, that becomes really easy. Why our particular solution is literally just a t n plus b plus b t n minus 1 plus blah blah blah, whatever, right? So this actually becomes, we can say yp is equal to some polynomial, and then we just do the exact same process over again. So this is a little shortcut we can use to solve these kinds of equations. So right here, I'm going to write down the table. So G is going to be here, and then here is going to be our guess, or yeah, it's going to be our particular solution. We have an exponential function like this. Then our guess is going to be a e. If we have cosine, so C cosine or C sine or some combination of these two, then we get A cosine plus B sine. And if we happen to have t to the power n, plus whatever, then our solution is pretty much just a to the n t to the n, right, of n equals 0 to actually this is not an n, I t to the I from I equals 0 to n, right? So that's going to be just our polynomial. All right, so hopefully that works. Yeah, very simple. I hope you can figure out how you can do that in practice. You basically just make that guess and then substitute it in and plug it in. Next episode, we're going to talk about a more interesting use of these things. Actually, I'm going to continue this because there's actually more to talk about for this method. I just remembered, because what happens if g is equal to e to the a the omega t cosine omega t and then plus t squared plus t, right? What then? And so there's a way for dealing with that. This episode has gone on long enough, and we'll talk about that in the next one.